Alright, well, this is ProwlerBot now at version about 1.8 here. As you can see, I've added some additional space to it. Got a upper deck now with some space for me to experiment with some new sensors. The new sensors that I've added at this point are the sonar sensors that you see here, here, and here. I'm setting up a sensor array on it so it scans through all three of those sensors if it needs to. Most of the time it just runs with the forward sensor, but if it wants to get side-to-side readings, it can quickly turn on the other two and scan them as well. And what I've got running that is a little pickaxe 20x2. It's taking care of firing each one of these sensors in order and recording the results for them. What then happens is the main board here, the parallax propeller board, is connected to I2C connection here, these two wires, and it can query through those two wires the values that this chip has most recently recorded for those sonar sensors. So in that way, the processor down here doesn't have to spend its time running through these sonar sensors, triggering them, and then measuring the pulse. It can just pretty much, whenever it's ready, query across the line and ask what the most recent value was. It's also got one of its internal processors. The parallax propeller has 8 internal processors. One of those processors is dedicated to managing that scanning process. So it is constantly updating just as fast as it possibly can get data out of those sonar sensors. It's also running a filtering algorithm on them to filter out any spikes or spurious readings. So every so often these cheap sensors seem to kind of go off the rails and give me either a 0 or some really long far distance. And then they go right back to reading what they were before. I've made a bunch of changes to the programming. I haven't really followed all my rules, so some of the sonar sensor processing actually takes over the robot completely. It doesn't give any time to anybody else while it's doing that. So if it's backing up or if it's trying to find a new place to go in the room, it's not paying attention to anything else. Something that would have to change over time. But the basic idea here is that the robot can now measure distances in front of it and to the sides and kind of figure out where it wants to go from there. Whenever it runs into an obstacle or runs into a wall, it will back up, kind of do the same thing it did with the IR, but what it's going to do is scan and look for a path that gives it enough distance to run its patrol again. So that way it doesn't just kind of bump around into things, it's actually looking for open space to move into. So I'll go ahead and fire it up here. And it's going to go through its initialization process, and you'll see those sensors get triggered once here. And then what we'll do is we'll go ahead and kind of send the robot on its way. Now we got a door right here and a wall over to the side. Now obviously if it were just making random choices, it could just as easily turn into that wall as it could turn into the more open area over here. So let's take a look at what she does now. Alright, we've sensed the door, and we're going to start making our turn. Sometimes those angled surfaces can confuse it, so there it goes. It's doing another scan. And then there at the end of the patrol maneuver, it does another little scan where it's looking for open space. And right now it's back into its watch behavior, which would, once we get our infrared motion detectors set up on here, that's what it would be watching. But it'll do this for 60 seconds and then it'll take off and move again. So it's going to scan again, look for an opening. It's getting a behavior pattern now where it tends to want to move into the open. And it wants to move along these long open spaces rather than just kind of bumping around. So now it's doing really more of a patrol, which is what I wanted in the first place, so that it's not spending all of its time bumping around in some corner somewhere. It's tending to stay into the open where it's got room to maneuver. We're heading off into the living room. Probably going to run into this couch. Like I said, the sonar sensors are not infallible. Anytime they run into a surface like this that's angled, especially a sound absorbent surface, it can be fairly invisible to them. Don't know any way around that, but it will eventually catch on to the fact that there's something in front of it and take action. So I'm going to cheat a little bit and kind of push it into that direction, speed this up. Now you see how that couch is just kind of invisible to it. But it works itself out of there. And now it doesn't make any turn here because it just sees that there's plenty of space ahead of it, so there's no reason for it to turn or make any changes. Every time it does the avoid, what you saw there at the couch, it always does, it always picks the direction that it thinks is most open, but then it will make a turn in that direction that is not part of the scan. What I was finding was just like there at the edge of the couch where it kept bumping into it, what was happening was it would do its avoid, it would go do the scan, and then of course that couch is still invisible to it, so it would try to move forward into the couch, and then it would run into it with the infrared detection, back up. The sonar sensor would say there's plenty of space ahead, and so it would bump into the couch again. So by adding that little spin turn right at the beginning that doesn't scan during that turn, it tends to get itself out of those situations where it's not able to see what's blocking it. And so it just did a second patrol move there, and it's still not going to change directions because it's still got plenty of space ahead of it. So if you see that little blinking light there, where right at the end of its maneuver it blinked all three of the sonar lights. That's how, when it does an avoid maneuver or when it's doing at the end of its patrol maneuver, that is how it makes its decision on which direction it wants to move. It fires the two sensors to either side, compares the readings, and turns in the direction that it got the reading that suggested it had the most distance. I see it got itself into a pretty tight corner back here, but it goes ahead and scans and gets right back out of it. And now once again it's looking, it's got plenty of space ahead of it, and it's not going to be making any turns. So some of the mechanical work that was done here was starting to use these Omni wheels on the rear of it. I'm sure you can kind of hear and see them in the video. I figured I'd give a little bit of a closer look at them. Each one of these wheels has the multiple wheels on the edges, so it can roll forward, and when it goes to make its turn side to side, those wheels just slide right along, virtually without any friction at all. So that gives it the ability to still use tank drive. This battery is starting to show signs of not being adequate as I start adding more and more circuitry to it. We've got a lithium polymer battery, a 2.2 amp hour battery, but that's proven to be a little bit small. I think I'm going to switch to a 4 amp hour battery. Hopefully that'll give me a little bit more operational time as we start adding more and more sensors here. Let's see. All of the other work was just basically machine work and getting bearings added to these rear wheels so that you can see they spin very, very freely. I wanted as little friction as possible. Same thing over on this side. And we still have just the two front IR sensors. I'm going to start working on adding the 45-degree sensors that we're going to go on this side, and then some back-end sensors too. Another thing we're doing is we're replacing this lower deck. I'm going to make it quite a bit wider. So if you look at the robot from above, let's see if I can do this where there's some light. You can see how the wheels kind of stand out past the edges. What that's causing for me is difficulties where anytime it finds a chair leg or a table leg or anything like that, it loves to hook those wheels onto those thin, spindly objects in the room. And then it gets stuck because it just sort of dances around that pole because it can't tell that something's happening. So what I want to do is I want to extend the plate so that it sticks out over these wheels and kind of acts as a guard for them and keeps it from being able to get hooked on things. And that'll also give me a little bit more mounting space for some of the stuff I'm doing. And then we'll start working on the accelerometer and compass module that I'm going to be adding to this thing. So that's where it's at right now.